Redo of midterm test. Question number 1. Using Biot-Savart rule, um, P vector magnetic field equals mu naught over 4 pi charge times the cross product of velocity and the unit radius vector divided by the square of radius. Um, Using the Pythagorean theorem, from the given diagram, radius equals 7.81 times 10 to the power negative 3 meter. Substituting the value of r, and the charge of proton is 1.6 times 10 to the power negative 19 coulomb. Substituting the values in the Biot-Savart formula, the magnetic field at the location C equals 0, comma, negative 1.78 times 10 power negative 17, comma, 0 Tesla. It only has the magnetic field only has negative y component. Its x and z component are 0. Number 2a. Since electric field is directly proportional to the square root of radius, the magnitude of electric field strength is higher at A than at B, because A is closer to the magnetic field than B. So the arrow at A is larger than the arrow at B, and their direction is toward the quadrupole. That creates the electric field. B. Electric potential is equals negative integral of electric field with respect to length dl, that is B equals negative integration E vector dot product dl vector. The potential at B is less than potential at A, that is Vb is more negative than potential at A. So voltage at B minus voltage at A is negative because both are negative. C. This is given electric field equals 1 over 4 pi epsilon naught h over x fourth, and the y and z components are 0. Using the definition of voltage from B, that is equals negative E vector dot dl vector, Vb equals negative integration of negative 1 over 4 pi epsilon naught h over x fourth dx. H, epsilon naught and 4 pi are constant, so I pick them outside, and the integration of 1 over x fourth is negative 1 over 3x cubic. So at x equals b, similarly at x equals b, Vb equals 1 over 12 pi epsilon naught dot h over b cube. So similarly, potential at A, Ba equals 1, following the same process, potential at A equals 1 over 12 pi epsilon naught h over a cube, and the difference of potential at B and potential of A equals 1 over 12 pi epsilon naught h, and times bracket 1 over b cubic minus 1 over a cubic. Number 3, dq equals lambda times dx. That's a linear charge density is the it equals change in charge over change in length. So, and using Coulomb's law, dE vector equals 1 over 4 pi epsilon naught dq over r square, and dE vector equals 1 over 4 pi epsilon naught. Substituting the value of dq equals lambda dx, we get this. Doing the integration, E vector equals lambda over 4 pi epsilon naught a square, and the integration of dx with respect to x is x, and its lower limit is 0 and the upper limit is cap is uppercase L. E vector equals 1 over 4 by epsilon naught lambda times the length of the cylinder over A square, and the direction is unit x vector. B. Uh, I, the first checking method is checking the units. The unit of electric field is Newton per Coulomb. 1 over 4 by epsilon naught times q over r length times negative a, and dealing with their units, the unit of 1 over 4 pi epsilon naught is Newton meter square over c square. The unit of Coulomb charge is Coulomb, and both radius and L have length m and their product m square, and A has the unit m, and simplifying this, the unit of electric field becomes Newton meter per Coulomb, and that's not consistent with the true unit of electric field. So the physical equation E vector equals 1 over 4 pi epsilon naught times q over r length is not a valid physical equation. And the another method of checking is checking the direction of electric field. The direction of electric field is toward positive x-axis, but 1 over 4 pi epsilon naught q over r times length suggests the direction is exactly opposite, that is away from the positive x-axis toward negative x-axis. So in another checking method is according to Coulomb's law, electric field equals 1 over 4 pi epsilon naught times q over r square and the unit direction vector of r. But here negative a 0 is a vector, and it's not a unit direction vector, and it has unit meter, so it clearly disobeys Coulomb's law. So the equation given in B is not a valid physical equation. Number 4, the charge is distributed like positive charge, positive, negative, positive, negative. They are aligned together in a neutral insulator. And B, C, and D, the electric the electric field due to dipole is directed to the left. This is the arrow, and the electric field um, due to the charges on the sphere is directed toward the right side, and they both are equal and opposite in direction, so net electric field equals 0. And the charge distribution is positive charge, they align in the left side of the um, sphere, and the negative charge they align in the right side of the sphere, and they are equal and they cancel each other. Mm. Since the electric field due to the dipole and electric field due to the metal sphere are equal, net electric field of the metal sphere is 0.